So this is a crash course in what a multiset is and the behind the scenes of the multi-choose. You don't need to know any of this to be able to use the N multi-choose K, but this is what's actually going on behind the scenes. So the first thing is what a multiset is. A multiset is just like a normal set. You throw a bunch of objects into your bag. The order doesn't matter of how you've arranged them, but the one new thing is this time it's okay to actually repeat your objects. So here it's totally fine to have two copies of, say, the element number 1 versus in a regular set, you would never have those multiple copies. Now, multisets have almost all the same things that you can do with sets, but they do have one additional thing, and the one additional thing is related to the objects being allowed to repeat. So cardinality is the same, it's still the total number of objects in your set, but you now have a thing that's related to cardinality called multiplicity, and this is the number of times that your elements are repeated. So multiplicity is attached to each distinct element in your multiset. So if you have the element 2 in your multiset, you'd say, hey, the multiplicity of 2 is the number of times 2 is repeated. So in a regular set, we also have multiplicity, but the multiplicity of every object is 1. Now, to indicate that we're dealing with multisets as opposed to regular old sets, the symbols do change. You get these things that look like greater than and less than symbols instead of the curly brackets like regular sets have, and this just indicates you have a multiset. In other words, don't delete the repeated objects now. Okay. So here's an example. We've got 1, 1, 2, 3, 3, 4, 5, 5, 5. And so we can ask a couple of different things about this. And for example, one of the things that naturally people will ask is stuff like, all right, well, what is the cardinality of M? Well, don't overthink it. You just literally count up the objects. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice I did go ahead and count each copy of the repeated objects. And you can also talk about the multiplicity of each of these objects. So for example, if we talk about the multiplicity of 1, we would say that's 2 because there's 2 copies. And then you could say the same thing for each of the other elements in the set as well. So then we see here that there's 1 copy of 2, there's 2 copies of 3, 1 copy of 4, and 3 copies of 5, which gives us all of our multiplicities. And if you've done everything correctly, one of the ways that you can check your answers of both multiplicity as well as cardinality is if you sum up all of your multiplicities, it should equal your cardinality. So here we've got 2 plus 1 is 3, plus 2 more is 5, plus 1 more is 6, plus 3 more is 9. So yep, that sum matches the total number of elements in your set. Notice many people do forget to worry about the multiplicity of elements that have just 1 copy because they're focused on the elements with at least 2 copies. In that case, if you forget any of your objects or your elements in your multi-set, your sum might be off. Now, multi-choose. This one here in terms of symbols looks like an N choose K, except there's an extra set of parentheses around everything. Here in terms of the formula, you add the N and the K together, subtract 1, put that on the new top, and on the bottom you just keep the K the same. So here this represents the N is the total number of distinct objects you have. So if we were dealing with the multi-set, the number of distinct objects here would be 5, even though there's a grand total of 9 in actuality. Okay? Now K is the total number of objects that you want to select, but now K, it's okay to duplicate, it's okay to repeat an element. So in terms of our chart, this is the one that lives where repetition allowed, but order doesn't matter. And order doesn't matter because behind the scenes, we're dealing with a multi-set. Okay, so here's some examples. Suppose you're asked to deal with N multi-choose 1. If we deal with N multi-choose 1, notice what happens. It says that you are selecting exactly 1 object from a set of N objects. repeats aloud, but you only selected one object. So in reality, you can't repeat anything. So there are n ways to select that. And if we throw that into the formula, notice what happens. You have n plus 1 minus 1. Choose 1. So this is n choose 1, which is n. So here we selected or chose one object. Now, what happens here? Well, here it says 1 multi-choose k. What this means is you have only one distinct object. So all of your objects are whatever that one thing is, and you want to select k of them. Unlike with n choose k, where the number k has to be between 0 and n, here the number of k can be as big as you want. So here we're looking at one distinct object, and you select it k times. So what does that mean? Well, since you only have that one option to pick from, there's only one way to select that one object. You don't have any choices. So here, if we look at the formula and see if the formula still works, our formula would be 1 plus k minus 1, k on the bottom. As soon as you simplify this, this would be the same as k choose k, which we saw earlier was the same as 1. Now, non-special case. So those first two were special cases. So this one here illustrates 2 choose 2. No, it doesn't. 2 multi-choose 2. So this one here says you have 2 objects. So 2 objects. And you want to select 2 objects. And repetition is allowed. So it's okay to pick the same object twice. So if we have a building set of 2 objects that's A and B, this would be the same thing as saying we want to build multisets of cardinality 2, so 2 objects in them, and those multisets only include the elements A and B. So, of course, we could have the multiset where we have A and B. And if we were just dealing with sets, that would be our final answer. As 1, there's only one option you could build. But in multisets, you can double up your answers. So both of these guys could be A, or both of them could be B. And notice now you have more choices because repetition was allowed, which means our answer over here is going to be 3. Now, let's check to see what the formula would give us back. The formula says you'd have 2 plus 2 minus 1. On the bottom, you'd have a 2. When we simplify this, this is 3 choose 2. 3 choose 2 is exactly the same as 3 choose 1. I just got this by saying 3 minus 2. And so we know 3 choose 1 is one of our special rules. It's just going to be a 3 for our answer. And notice, again, we got the exact same answer that we got when we looked what was going on in the multisets. Okay? So that right there is the crash course in terms of multisets and how they relate into the multi-choose stuff.